that's okay. So hopefully maybe a few people will wander in as we go along. But as I said, we're usually fairly informal. And Plastic Free Delaware, as you may know, for those, I think everybody on the call, knows who we are and what we do. And we're the statewide organization, mostly trying to address single-use plastic, but also segueing into the larger realm of zero waste. Debbie Mulrooney is on our working group and board, and so is Richard Trask. So thanks to them for being here as well. So I was really excited when I saw the release of their report, RMI's report on plastic packaging and the connection to climate change and petrochemicals, because I think not everyone understands that plastic pollution is really connected to climate change. So I've been trying to do more and more of our work in that realm and trying to get, more educational work out there about that connection so people understand it better. So I was really excited to see your report, and Joe and Sasha are here today from what I used to remember as the Rocky Mountain Institute, but I guess now you just go by RMI, right? So
Yes, we're still trying to transition everyone to saying RMI, but
yeah.
that's good.
So if it's okay with you, I'll just turn things over to you guys, and you should have screen share ability if you need it, and I'll just let you go take it from here.
Sounds great. I'll share my screen, and maybe while I do that, Sasha, if you want to introduce yourself.
Yeah, thanks, Joe, and thanks, Dee, for having us on this Lunch and Learn. My name's Sasha. I'm an associate on what is called the Climate Intelligence Program, and within that, Joe and I sit on an oil and gas solutions initiative team. So we analyze the oil and gas sector across all of its segments, balancing supply side emissions reduction interventions with overall transition, energy transition strategies. And I think specifically on plastics, our work started about 2 years ago, broadly in petrochemicals and refining, and has since narrowed down to these specific sectors, and we've built out a whole team dedicated to it, thanks to Joe and a lot of the other teammates. So it's exciting to be able to share our work.
Thanks, Sasha. And I'm Joe Fallurin. I'm the manager of the oil and gas markets team within the Climate Intelligence Program that Sasha mentioned. And for those not too familiar with RMI, formerly known as Rocky Mountain Institute, we seek to create a cleaner, prosperous, zero carbon future for all through the use of radical efficiency in both materials and energy, which is why plastics definitely shown through as an area for improvement on both fronts. And yeah, we hope you get a lot out of this presentation as we go through it. So take us a little bit of a step back into the why. Plastic climate impacts are affecting all of us globally, every community that we have, just differently. And I wanted to highlight this through the graphics on the right here, tried to be very specific to your state. Overall, Delaware is kind of middle tier in terms of climate vulnerability compared to other census tracts in the United States, as you can see with the blue graphic. But on the right here, if you break that down, even within Delaware, you'll see lots of different differentiated risks, right? So extreme events are more concentrated in northern parts of Delaware, and that might be hurricanes. It could be just extreme precipitation events, as we've seen those increasing, or wildfire air pollution effects. And then on the bottom right here, you can see health impacts are more concentrated in the southern part of Delaware, where you might have increasing tropical conditions, more standing water from flooding conditions, and that cumulative impact adds up. So we often see these end results of climate in specific ways like this, but we often don't see the greenhouse gas emissions that ultimately cause these climate effects. And I hope that we can try to paint that picture a little bit and connect the dots for you on how plastics ultimately connect to these events that we're increasingly seeing. So these are kind of the summary points, but plastics, as we know, are quite large as a sector, and they've been growing very quickly. Climate impacts overall, not just specific to plastics, are mostly non-carbon dioxide in terms of current heating, and we'll get into that a little bit later. They are predicted to drive a significant share of future fossil fuel extraction. And because of these aspects, they are quite variable widely in the now. We've done a lot of work to show how different plastic climate emissions can be depending on the supply chain route you take. And because of those differences, we can take advantage of them to ideally lower them with better designed systems and processes and regulations. And I know this is a fairly casual group, so feel free to jump in with questions as needed. Okay, so let's start it off with size. So plastics are growing quickly, right? So for some context, over the past 50 years, we've seen other materials like steel grow about 2 to 3 times over in terms of the actual material flow. We've seen global economic activity, gross domestic product, rise about 4 times over in that 50-year period. And we've seen plastics flows increase 10 times. So almost double the rate of GDP. And that growth has really snowballed into some pretty massive effects on the climate. So plastics are a subset of petrochemicals, which are a large industry that cover not just plastics, but rubber for your tires, the artificial countertops you might have in your home, or resins that you have in tiling in your home as well. And overall, that sector, depending on how you draw your boundaries, as you can see in the bottom here, going from left to right, that can add up to about 3 to 10% of greenhouse gas emissions caused by humans. And plastics comprise about a third of that. Most of that is concentrated at the primary chemical plant level. So if you're familiar with the supply chain, think of the steam crackers that are very heavily concentrated in the US Gulf Coast in industrial hubs near oil refineries. And RMI, particularly Sasha, actually did a lot of work scoping that out back in 2022. And there's been a huge coalition of partners that have really teased out and calculated the effects in different parts of the supply chain, as shown with that growing boundary there. So that's generally what we know about in terms of climate impacts, but it is still a science that we're learning more about. So there's a lot of induced climate impacts that's kind of the frontier of what we're trying to quantify. RMI is specifically trying to lead on quantifying methane leaks that are co-produced and co-released from the oil and gas extraction process all the way through to plastic manufacturing, and that's ongoing. But on the other side, there's unique interactions between plastic waste and nature, different second order effects that can be had from potential interference with photosynthesis and other aspects of the carbon cycle that we're really just starting to get into. A lot of studies still needed in this place, but there's some great groups that are trying to foray into this. And part of that is because, plastics have only really been around at this scale for less than 100 years. And 100 years tends to be the time frame in which we measure climate impacts. So you'll often see greenhouse gas metrics on a 100-year basis to equate them to carbon dioxide. But climate change isn't just a 100-year problem, right? It's something that we're seeing now. And so if we reframe that 100-year context back to the now, and we look at all the greenhouse gases, we can see carbon dioxide is still the biggest, but it is not the majority of the cause for current global warming. So a lot of these are intimately tied to different aspects of the plastic supply chain. Carbon dioxide is most well known, but methane, carbon monoxide, volatile organic compounds, black carbon, and nitrogen oxides, all of these are released in different forms of combustion, which typically happens to process a pellet. If you have well-designed combustion, you should get mostly carbon dioxide. If you don't, if your burners are dirty, you just have a poor design, you might actually generate some of those other red and orange compounds that I mentioned, and that could have an outsized impact. So specifically methane, as mentioned earlier, RMI does a lot of work there. Pound for pound, it's about 80 times more powerful than the same pound of carbon dioxide over a 20-year period. So that can have a pretty outsized impact, and methane is basically natural gas. So it's co-produced all along from the start of the supply chain to burning in a refinery or a steam cracker. Fluorinated gases in orange there, those are effectively co-produced with plastics at steam cracker facilities. So, think of those as refrigerants, the worst of which were the CFCs banned by Montreal Protocol back in the 80s, and we're starting to phase out the next worst ones through a Kigali Amendment over the next year. And then nitrous oxides are also a product of mainly natural gas converted into ammonia, nitrogen fertilizers once they decompose out in agricultural fields. So plastics are fairly intimately tied to all 7 of these major global warming pollutants. And yeah, I think I'll pass it over to Sasha at this point.
Okay, thanks, Joe. Feel free to hop in on this slide too if I miss out on anything. So the plastic, petrochemical, and oil and gas industry overall is essentially banking on plastics to replace a large subset of their product that gets displaced by fuels. So from displaced fuels in terms of electric vehicles or in new innovations in shipping and aviation, this is leading to the biggest chunk of oil demand decline. And plastics is expected to increase its share of oil demand from 12 to almost half of oil demand, even in IEA's net zero scenario. And you can see here also the split up. One of the things we'll get into later is essentially the complexity of this sector and numerous amount of pathways. So it's not just simply oil, but also gas and sometimes even coal. And Joe, I think either you can add anything here or you can go to the next slide.
Yeah, thanks. I'll move to the next slide.
Great, thanks. So one of the first steps of our team's overall theory on how to incent structural change in the sector starts with emissions visibility. So gaining a more accurate picture of the profile of emissions in the sector. And one of our most consistent findings, as Joe mentioned, is that methane is both undercounted and overlooked as a driver of these emissions footprints. And so on the left here, you can see these are essentially a graph of different types of oils and gases around the world that have a vastly different emissions footprint based off of the geology of the resource, based off of the operational practices and the all the technologies used to essentially get that out of the ground. And this, you can see from the highest bar on the right to the lowest, that's a difference of 10, a factor of 10. And methane is a driver in that. As it increases, you can see the methane in blue is comprising oftentimes more than half of each of these resources overall footprint. So that's the first step of plastics, is extracting those resources. In terms of the next step, which is refining and processing, refining crude oil, converting that into a polymer, and then shaping that into a plastic product. This also has a ton of variability. You can see here we modeled a polypropylene like Tupperware container, 2 different pathways of the emissions footprint of that. And it's a factor of 3 times. And this is driven by things like the efficiency of that petrochemical process, the steam cracker, as well as where you're sourcing power from. So after that product has already become a plastic, all that's left is essentially shaping and molding and transforming that into a product. And in scenarios when those steps are electrified, that results in huge emission savings. So that's another factor that can drive the difference there. And then lastly, we know that one of the main legacies of plastic is its waste mismanagement. And this is the area with the highest amount of variability due to a lot of data uncertainty, due to the difficulty of tracking and collecting data in that. So this is different disposal methods of plastic. We know generally landfilling plastic has generally a low emissions footprint, although there are complicating factors, whereas incinerating, burning the plastic can almost exceed the entire production footprint of making that plastic. And that kind of goes back to that previous point about oil demand being increasingly towards plastic if it's not combusted at the end like a fuel would. That's touted as an emission saving measure, but if it's so mismanaged that plastic ends up getting incinerated, it's a very dire climate consequence. And so in between the middle of landfilling and incineration is a whole suite of what we know as recycling. And even that can have a factor of 10 difference in the greenhouse gas emission footprint. So the most common one that we know of, mechanical recycling, that's general curbside recycling. And then there's a lot of new investment from industry in what's called advanced or chemical recycling. And this has lots of different methods, with the most common being called pyrolysis or conversion. So those technologies generally use really high heat to reconvert a plastic waste product back into its polymer form. And so that's generally a lot higher in terms of emissions intensity than mechanical recycling, which is shredding, cutting, and reforming. And so all of this variability points to the fact that there are pathways for suppliers and producers of these products. There are pathways that they can prioritize that lead to emissions cuts, and that these are available for them. Joe, you can go to the next slide.
Yeah. One more thing to add on the bottom right there, you could see that that conversion pyrolysis chemical recycling step that Sasha mentioned, it may actually result in more overall life cycle greenhouse gas emissions than just typical fossil-based plastic and landfilling it. So just wanted to point that out there.
Okay, so speaking more about the complexity of the sector, this is even a streamlined version of the thousands of products that petrochemicals can make. And excuse me, one of the ways we attempted to simplify this is on the left here is categorizing out some of the essentially what is called high value chemicals versus ammonia and methanol, which are more often large industrial buyers and uses of the chemical products. And so within high value chemicals, if you only include that, what we know as the common products by their recycling codes, like 1 through 6, those comprise about half of all petrochemical demand. And if you take half of that amount as well, that's the amount that's dedicated towards packaging and film. So we know that packaging and film is essentially one of the main drivers of the whole supply chain and business, essentially. And these figures are based off of our reports. So if you want to take a closer look at them, they're available there. But essentially what these figures show is a chemical on the left-hand side, a intermediate product type in the middle, such as number 1 PET or number 5 polypropylene. And then on the right, the conversion process that's used to convert those into final products. And this is sized to their magnitude. And you can see on the right bar chart that each of these 1 through 6 kind of have their own specialties and the areas that they go to. With PET, you see that's the most common material for plastic water bottles, as well as you see that lighter red shade, which is fiber, and that's actually polyester for clothing. For number 2, high density polyethylene, that is one of the most variable classifications. So a lot of rigid packaging. For PVC, we see a completely different profile. It's oftentimes used more in construction and building applications and durable applications. And then low density polyethylene is mostly for films, soft plastics, bags. Excuse me, I'm going to grab some water real quick.
Sure. I could keep going. Polypropylene is similar to HDPE in a variety of uses, including packaging, certain types of fibers for carpeting, and some medical applications. And polystyrene is kind of a mix of packaging and specialty uses like insulation for appliances. Any questions? Sure. Great. Should I move to the next slide, Sasha?
Yep. All right, so we'll take a couple slides to do a little bit more of a deep dive on packaging, since it's, clearly one of the main drivers of these impacts, as well as oftentimes the most visible sector in terms of attention to the public as well as policymakers. So we already mentioned that half of the commodity plastics ends up as packaging or film. To give an emissions equivalent, a 612 million tons of CO2 equivalent, that's roughly the same as 1/3 of the US transportation emissions. So driving, flying and shipping, all of the United States emissions there, 1/3 of the emissions of that is equivalent to 1.5% of global energy emissions, and also the same footprint as plastic packaging. And in terms of the waste as well, which is, as I mentioned, one of the main categories, with less than 5% of plastic packaging avoiding a landfill, avoiding an incinerator, or avoiding being leaked into the environment. That makes it the packaging material with the lowest reuse and recycling rate. And this isn't just a waste management issue, because this has tiebacks to other climate consequences. For example, we'll talk a little bit later about food waste specifically, but food waste, food that is landfilled in a plastic package, that will result in higher methane releases from that landfill. Incinerators have huge greenhouse gas and air toxin implications as well. So this isn't just a concern for material reuse and recycling, but it also dramatically adds to the climate footprint. Next slide. And so one of, as zero waste aficionados, this audience is familiar with waste diversion hierarchies, with things that are prioritized, levels of priority, from refusing to even buy a product to last resort being landfill. I'll just go really quickly, pointing back to that initial slide I presented about supply side measures that can lead to emission saving from constructing plastic. from that previous slide, it's also clear that we need to address the demand side of things to reduce the sheer volume of plastic that is packaging that is bought and brought into circulation. And so how the key question for us and many others is, how can this be done? How do you keep the core functionality of packaging while minimizing the adverse impacts? And at the foremost step is removing things that are superfluous, unnecessary, and otherwise problematic to either the waste collection stream, or they have high toxicity, they have high greenhouse gas emissions, otherwise problematic if they're not serving a unique function and they're removable. Those items should be subject to bans, as we've seen gaining momentum for specifically polystyrene, which is a nod to your great work there. In this second category is this area of circularity and different business models and interventions that can increase the length of time that a product is used for. So I say replace here in terms of, if you can replace something that's traditionally plastic with what it might have been before plastic became the mainstay, it is likely to also have higher rates of reuse and be used for longer. And for reuse specifically, when we think about packaging, things are either being delivered or transported, and that's the function of the package. So if we can find replacements for that essential function, then it is redundant to have plastic as the medium for the packaging. So this can be seen in an example of like refilling like either food goods or cosmetic goods that are in like a dispensing type of station where you bring your own bottles. It can be seen in things where you have a local system to drop off a container that will have a centralized system to clean and redistribute them. And so this concept of, there's a myriad of solutions here that were oftentimes used before plastic was the dominant way to move around goods, whether it's delivery or in person. And then this last triangle here is the redesign of packaging. So after we've removed problematic items and we've made cuts to demand by substituting materials and substituting systems, we can then redesign the plastic that remains to be highly reusable, make it highly recoverable and recyclable, essentially. And what an example of this is making things out of the same type of material. So the previous slides, oftentimes packages will have multiple types of those polymers. It could have a lid that's one number type, and the bottle is another number type, and that renders the whole thing not able to be recycled. Same with colors and additives. These things are impediments for the recycling systems, and especially for mechanical recycling too, which we know is the lowest greenhouse gas intensity way of recycling. So redesigning what remains to be essentially streamlined, to being clearly labeled, to being one type of material, essentially really simplifying the package design to be fit for a system. And then we'll actually see that 5% number increase dramatically if there's a lot less contamination, essentially. Thanks, Joe. And so there's a couple key stakeholder groups that have actions on the table that they can enact. One, to start off, the packaging manufacturers. What's been the industry norm for them and what they've sort of claimed to propose as their sustainability strategies is to do things like recycled content targets. So they'll have an increasing percentage of a package that is made from recycled content. And then this second bullet on the left is what I was mentioning about monomaterial, one material or same material, and trying to decrease the amount of material used in a package by making it more lightweight. So those are the two of the things that companies at the forefront of this transition have started and are currently doing. But there's much more room to go. So for those that aren't doing those are a great first step. And then for kind of the next tranche of advancing these goals would be to have emissions accounting methodologies that actually are specific to the product. A lot of reporting and disclosure about emissions accounting oftentimes is lumped into, the company overall, maybe by facility. There is a lot of room to improve the granularity of how specific emissions accounting can get to a point where a consumer can see a package, can know the attributes of the package. Whereas currently we have to do a lot of research to know that polystyrene cup is both not recyclable and a lot more emissions intensive than another type of plastic. So that's a major room for the whole manufacturing stakeholder to improve on. With this also becomes recognitions and certifications for things that are designed according to those priorities of lightweight, single material, no toxic additives. There's an increasing realm of groups that are offering certifications and standardization for these things. And that will overall lead to more efficiency and incentive for the companies to go out and do these things. And then in line of connectivity across supply chain, a buyer in an ideal world should be able to differentiate what they purchase as their supply based off of emissions attributes or other sorts of attributes that can be distinguished by these design certifications. For the middle column, like consumer packaged goods companies, it's a lot of also feedback with the manufacturer, the consumer. They're kind of the ones that currently have big commitments around recycling, either if their package is recyclable or they're using recycled content. But there's currently really no transparency or accountability to those targets. So in the same line, groups that haven't done that is the starting step. But for those looking to go the next level, it's about those same topics of eliminating packaging that they know is not recyclable, changing the design of their products, and keeping feedback between the manufacturer, the consumer, as well as the waste authorities in the jurisdictions that their products are sold in. And this is, excuse me, can also lead to certain products of a company's portfolio that are differentiated, and this can be seen in some companies currently. And then the last category of governments, whether that's local, state, country, or as we now see momentum on a United Nations Global Plastic Waste Treaty, there's a whole slew of levers available to them. Things that have been ongoing for many years are local and regional product bans, whether that's a product or a polymer type like polystyrene, styrofoam, or bags is another common one, as well as levying fees for those. And sort of the next step for this area is to harmonize a lot of those requirements and laws within regions, counties, states. That's one of the things that the recycling community points to as the #1 issue plaguing them, is that rules are different from city to city, region, county to county. And for those in which that is the case, harmonizing those is a really important step, as well as this concept of extended producer responsibility, EPR, which is essentially the accountability mechanism that brings back the burden of collecting and processing waste onto the company that brought those products into circulation. So that's an emerging avenue that hits on both the financial side of things of how all this waste collection can actually be financed, and as fees from the companies producing them, that is seen as a good avenue going forward. And I mentioned the Global Plastic Waste Treaty that is currently ongoing. There's a lot of questions about what form it will take, if it will solely focus on waste, if it will have production limits based off of certain country profiles and their overall position in the industry. So that is something that us and other groups are vouching hard for, to have comprehensive and sensible guidelines. And those are the same questions that we talk about here, the trade-offs between reusable systems and where plastics do have a beneficial role. And so those are the questions that community is currently stumped by and trying to harmonize. I think if you don't have anything else, Joe, we can go to the next slide.
Great. I think this was mine, right, Sasha? Or
yeah, you can go.
okay, great. Yeah, Sasha did a great job leading the packaging overview, but we also did a similar analysis of the textile and building sector to try to tackle all three. Recognize that packaging was mostly the focus here, but wanted to just advertise that we did do a similar analysis, and saw major opportunities to reduce textile demand for petrochemicals. We're seeing a growing trend to normalize local resales in a lot of regions, and we can certainly accelerate that. It's already one of the fastest growing parts of the fashion industry, and we hope it accelerates further. On the buildings level, RMI has been a leader on carbon-free buildings for nearly its entire history. So we were able to leverage a lot of in-house experts to show how good community plans and development strategies that reduce built distances and that can ultimately snowball into reduced petrochemical use in buildings and transportation systems, interconnections, including piping. And there are several viable alternatives now for PVC and polystyrene in a whole host of building applications where there really doesn't have to be a major sacrifice, and there could even be health improvements in many cases, including reduced healthcare costs for community members. There's also a lot of mineral-based solutions for paints and countertops that can be lower intensity as well. And overall, across the board, there just appears to be ripe opportunities for material efficiency, primarily through orienting towards a reuse and a repair framework. So treating our goods as assets instead of just a pass-through flow system. If we do need new materials, there are sustainable bio-based alternatives out there. There can be more to better describe and accurately compare those to consumers, and we hope to develop some of those in the future. And there are some unique opportunities for recycled closed-loop material applications, maybe even from packaging and textiles into buildings. But those need to be similar to bio-based, carefully assessed. And in case you're wondering if this is impossible, we've already kind of done this with transportation. This is a common criticism, right? But most people don't realize that we have peaked not just normal combustion engine passenger vehicle sales globally. We've peaked all individual passenger vehicle sales. EVs get a lot of the attention, but the overall efficiency and reduced demand of the individualized car system overall has already started. You might also see a lot of the amount of plastic or the share of plastic in vehicles increasing as more batteries are loaded up to help offset weight. But even that increase on a per vehicle basis doesn't offset the reduction in total vehicle demand. So we're here to show that applied hope does work. It just doesn't work in every sector at the same time. We also wanted to get to the food waste aspect that Sasha mentioned here. So a big common criticism is, plastic stops food waste, and food waste is a bigger greenhouse gas issue. Food waste is a large greenhouse gas issue. This is abundantly clear, both on the upstream side in producing it and on the waste side as it decomposes into methane in landfills, as Sasha mentioned. But that doesn't mean that it's always more plastic will always reduce food waste. So we did a pretty high level analysis for what do countries use on a per capita basis for single-use plastic, and what are the best estimates for food waste. We tried to simplify down to the highest quality data out there. As Sasha mentioned, waste data is notoriously tough to track. And we're really seeing that there's no clear correlation between using more single-use plastic at the rates that we're using them and food waste generation. So it's at least an indicator that it's not a very clear relationship, and there have been isolated examples where we can potentially reduce plastic and be independent of food waste generation. So thank you for your time here. We'll open it up to questions, and we've also provided links to the reports if folks want to learn more.
I had a
Wow.
couple of things.
Go ahead, Diane.
Um, First of all, Dee, was it your event when we talked about Eve Schaub and the Year of No Garbage, that book?
She was our guest a few months ago. Yep.
Right, right. And she drove home the point, I thought very effectively, that we can only do so much as consumers, that the bulk of the change has to come from the producers. We can't recycle our way out of this.
Correct.
But it has to be cost effective for the producers as well. So, you know, is the government looking at incentives rather than just sticks? Are they looking at any carrots to make it worth the while of the producers to rethink their packaging?
Yeah, that's a great question. I think a lot of the policies currently at least build off of the sticks needed, just because, as I'm sure you're aware, the cost is so ridiculously and you know easy to debate artificially low that you need to kind of get closer to the true cost to create enough of a bandwidth for incentives. But that said, I know there's extended producer responsibility regulations proposed out there that provide bonus credits for innovative packaging solutions that can prove that large reductions in impact, not just greenhouse gas, but other environmental and health impacts can be achieved. So that kind of builds off of that point. There's also the Inflation Reduction Act federally indirectly could provide some incentives for decarbonization investments. So green hydrogen use could be a decarbonization avenue for the production side where most of the embodied emissions are. And yeah, anything else to add to that, Sasha?
And I wanted to ask you, on one of your slides, you used the term built distances, reduced built distances. I don't know what that means. I even tried to Google it and I couldn't figure it out.
Yes, I wouldn't say it's a common industry term, but this can range from, at a building level, being materially efficient and not adding a more surface area or square footage than is really needed, or additional external features and finishes that are excessively aesthetic. It could also mean better infill development of existing communities so that you don't need to run a new 2-mile PVC water pipe all the way out to a new development.
So the opposite of sprawl, sort of.
Yes.
Yeah, that's interesting. I've never heard that term either, Diane. So thanks for asking that question.
I have noticed that the manufacturers are cutting down on the packaging. I don't really drive much, and so I order most stuff to be shipped to me. And what I've noticed, a few big things, I've noticed a lot less packaging with Amazon. I'm throwing away a lot less stuff when I get a shipment. Omaha steaks. I just got Omaha steaks, and instead of coming in a big styrofoam container, it came in a lined paper container. So I can see that we're starting to have an impact.
Yes, I've been to a few conferences where they really pride themselves in these case studies, major companies in packaging reductions, and as you said earlier, it can't be all in the consumer, but the signal is, I think, really starting to come clearly through on the business side that packaging is a cost ultimately to the consumer, and there's more and more pushback on absorbing that cost.
Are you making any headway with electronics? I know that you're advocating, and rightfully so, repair. But our microwave went recently, and they said, nope, we don't repair those. You just have to get a new one. And I think my family has a file cabinet drawer full of cell phones. What do we do with the electronics? Are we making any progress with that?
Yeah, I don't think we've gotten to the electronic level yet. But I don't know, Sasha, have you come across anything?
So I think the idea I mentioned about EPR, extended producer responsibility, is actually more developed in the space of electronics and e-waste, I believe, than it is in for example, packaging and plastics. So a lot of those right to repair and extended responsibility has actually started in that realm, and now it's like trying to be applied to other areas.
We have had a right to repair bill in our legislature the last couple years, but it wasn't quite the bill we wanted. We weren't the spearheads behind it, but we hope to bring back a better bill in terms of right to repair. And I think Colorado actually has a good right to repair bill, don't they? If I'm not mistaken, for electronics. Because I think your waste network throughout the state is a little bit different than Delaware's, but the whole right to repair movement is definitely growing. And I think, I don't know if it was Sasha or Joe alluded to earlier, about the disconnect between all the different local governments and laws and stuff. But the problem is that there's no action being taken on the federal level. Debbie is keeps track of all the congressional laws for us right now, but they're just, nothing's moving. There's a lot of proposed laws to address plastic pollution and a bottle return bill and that sort of thing, but there's just nothing happening in Washington right now. So, Sally, I see you have your hand up.
Yeah, thanks. Could you all comment, please, on the use of bioplastics and compostables as substitutes for single-use fossil fuel-based plastics? And secondly, I'm really confused now about what to do with my own plastics, given that I might put them in a recycling bin. They might be a number one, or they might be another supposedly acceptable one. They might end up being burned in municipal waste here or abroad. It's better just to put them in the trash.
Yeah, that's a great point, and points to the whole complexity. Sometimes more complexity is not the right answer. I would say that you can have bio-based and compostable or biodegradable are somewhat independent. You could have an entirely bio-based plastic that functionally acts the same, chemically identical polypropylene HDPE, and therefore you can't manage it the same way. There are also instances of fossil-based biodegradable plastics. Not saying that's the ideal, but there are some routes that could, in theory, go to industrial compost facilities. And I think one thing that shown through in our work and our landfill team's work is composting facilities and infrastructure and education really needs to scale up faster across the board before we really scale up these the supplies of them. And yeah, compost systems across the board just really aren't keeping up.
Delaware certainly being one of them. Delaware doesn't have any industrial scale composting going on, but the perhaps good news is we don't have any pyrolysis going on either, although we're not totally sure where our captured, recycled plastics are going. It's a conversation we've been having. Are they going to some other state that does have pyrolysis, like right next door in Pennsylvania?
Yes. So that the other half of my burning question, personally, what do I do with my plastic stuff?
Yeah, I know that the BPI certified compostable label does a pretty decent job. So if you do see that, that should be compostable, but I would say, depending on your local requirements, it's probably safer not to recycle compostable.
I'm thinking of the number one stuff that food comes in sometimes. Better to put it in the trash or better to put it in recycling?
Are you in Delaware, Sally? Yeah, I mean, if you put it in the recycling bin, it's going to go to our recycling facility, and hopefully it is. I mean, like Dee said, we're trying to figure out where this stuff goes. We know they are recycling some of it, maybe a lot of it. It's not getting burned. I mean, it'll get to a good place, better place if you put it there. At least it has a chance of being recycled if you put it in a recycling bin, because they do collect it all and they do sort it all. Yeah.
One related issue we've been talking about as well, and you made me think of it when you were talking about the, just products that have a mix of chemicals in them, and just made me think of the resin code laws that 1, 2, 3, 4, 5, 6, 7, whatever it is. It's set from what you're saying. It sounds to me like those numbers don't even get close to where we should be. Maybe the resin code system needs to be vastly updated to really reflect what this stuff is made of. And part of what my pet peeve is, I want to do away with the chasing arrow symbol, at least for those things that are not truly recyclable. They should not have the chasing arrow symbol on them. But the law is tied up with the resin code number, but there's no reason why you couldn't have the resin code on there, just not surrounded by a chasing arrow symbol, so then at least people would know what it was made of, and if it's not recyclable, it wouldn't have the arrow. So anyway, that's on our radar screen.
Yeah, we've definitely tried to keep track of the Federal Trade Commission's Green Guides updates on the chasing arrow side, and we were pretty pleased to see that ASTM, the American Standard Testing Body, has already said they're gonna move over to triangles and away from the chasing arrow system. So good example of the private sector taking the hint and moving before the regulations hit.
Will that if and when they make that changes like that though, how will that impact local laws?
Yeah, that's a great point. It's not too clear to me how that will shake out. I don't think we've tracked which local places require the chasing arrow symbols. Is that correct, Sasha?
I think from my understanding, it's been a while since I started delving into it, but it's something like 35 states, something like that, because back in the 80s, I think it was, the industry went around thinking it was a good thing to get this section of code in as many state legislatures as they can. And of course, now looking back, things have become more complicated. So it's not as simple as it once was back then in terms of materials, how we use that symbol. But
yeah,
Diane, did you have your hand up?
Oh,
Or
go ahead.
sorry. No, okay. Sorry, go ahead, Joe.
Oh, yeah, there's been pretty interesting innovation on, like you said, adding more information without getting into too much complexity on the resin code side. So Digimark is one example where you could add more data. There's QR codes, RFID tags, lots of other digital ways to kind of embed more information, ideally something like a carbon footprint one day, but maybe more information on additives and ultimate compositions to add transparency.
I ran into the head of sustainability of PepsiCo at a conference last weekend, and although he talked about their goals of circularity, he spent most of his time talking about recycling and, the whole every bottle back campaign that they have. I'm sure you've all seen their ads on TV. And, but, as Joe and Sasha alluded to, or the recycling rates of plastic, like single-use plastic water bottles, for instance, is so low. It's about 5%. So, and I made the point to PepsiCo that, that's not the solution. And like you were saying, just reducing the amount of plastic. Of course, I'm sure you've also all seen how water bottles, Coke bottles, whatever, have all gotten very, very thin. So yes, they're using less plastic, but the end result is really still the same, where it's 9 times out of 10 going to the landfill or going out into the ocean or whatever. So I think PepsiCo and other companies really need to do a better job of, but maybe taking more than those first 2 steps that you mentioned. But he spent a good bit of time talking about the Colorado EPR legislation and effort. So he held that up as a model that seemed, that they were supportive of. Well, I think I have to listen to the recording again and absorb everything that Joe and Sasha covered. Does anybody else have any questions? We'll be posting the recording on our YouTube channel. So if anyone like me needs to listen to it again and be able to really delve into their graphics and everything a little deeper, it'll be up there very soon. So any other, I think we're all in shock and we need to just delve in a little bit deeper to your report. And I thought it was really interesting what you said about the cars and how we've reached peak plastic and peak single-use vehicle, single occupancy vehicle peak. I loved your term applied hope. Is that what you said, Joe? Yeah, that's
Yes.
awesome. Sally, what, you had a question?
I just am not sure where to find your YouTube.
Okay, if you go to plasticfreedelaware.org, our website, there should be a couple different places you can find it in the footer, and there's a social page and that sort of thing. It should be linked there.
Thank you.
Yeah.
Great. Well, thank you very much, everyone. Happy to follow up. We can share our emails, and if you search for either of our names at RMI, you can get a whole host of our backgrounds, emails, and links to our reports. So thank you again, and thanks for joining our Applied Hope train.
Thank you so much to you both. Have a great afternoon, everybody.
Thanks.
Okay.
Thank you all.
Okay, so take care.